Welcome to part 7. We just loaded the car and it's going to a shop to have the trunk floor replaced. So a bit of a cutting and welding job. We loaded the car this time with a $50 winch from Harbor Freight and it was so much easier. Really a great purchase. So yeah, we're going to rinse it off. There's the new wheels. I'm going to rinse it off and then haul it into town, and then after we unload it at the Camaro place, we're going to pick up the engine and then pick up some powder coated parts. So yeah, fun day, and then we'll spend the rest of the time assembling the engine. Okay, we got the car all strapped down. Got a big old strap over the rear axle and another big strap in the front going through the suspension, a couple of chains plus the winch. I think we're ready for the road. We're also going to take some suspension parts. Might have the shop do some extra work besides just the floor. This shop we're going to is called Camaro Concepts, and all they do is old Camaros. So they're specialists for this particular model, first generation Camaro. So good contacts to have for sure. There may be other things that we need them to do in the future. Alright, today we start the assembly.
Some dirt out of that.
So cleaning out the oil passages, making sure there's no debris in them. We're also using these little thread cleaners and running them through the bolt holes just to make sure they go all the way down. These thread cleaners have a little groove cut on them. Cleans out any debris. So we've got a whole set of these. Alright, we got some of the crank bearings in. Here's the thrust. So now we're getting really heavy rain. So it's going to be hard to hear the audio, this much rain, but yeah, this is supposed to happen all day long. So good day to be working in the garage. Right now we're doing some measurements on the inside of the crank journals and comparing it to the crank itself and checking the gap there. That'll be the oil gap. So I'm sure the machine shop did it correctly, but just double checking some measurements. So this is plastic gauge, a small piece of material that will get smashed flat when we put the caps on and torque them down. Then you measure how flat they get, and that tells you how big the gap is for the oil. So again, just double checking the machine shop's measurements. Okay, the plastic coat is smashed down and you can see it hopefully right there, and it lines up with the 0020 clearance, which is correct. That's the correct clearance for the bearings. So that worked. Validates the right size bearings. So we got oil on this surface that matches up against the crank. Black RTV on the back side of the seal and on the mating surfaces. So this is about ready to go together, I think.
So it's going in just, yeah, it does go in.
So that's 6 1/1000ths on the crank in play. Okay, so it's 2 to 7 1/1000ths is the spec for that gap right there, and that's the crank in play. So basically you push the crank back with a screwdriver all the way to the back of the engine and then measure that gap going from the thrust flange to the thrust bearing. And we're at 6 1/1000ths, which is within spec, so that's good.
Try to be liberal with this.
So this is the assembly lube, which is a very thick oil that stays in place until you get your motor oil circulating after the engine is started for the first time. Okay, this will be the final torque to 75 foot-pounds. We've got the crank spinning freely. Feels very smooth.
Going to fits, it's tight. So we don't want it, I don't think we want it that tight. I think we ought to lightly grind it.
Perfect?
Mm-hmm.
All right.
Well, I got to chamfer it.
So the way this works, we put in the ring, we measure this gap right there. And if the gap is too small, take it out and grind it on that wheel, diamond wheel. This device allows you to get the ring at the right position in the cylinder, so squares it up down the same amount all the way around. Okay, just to run through this process in a little bit more detail, now that the rain is letting up a little bit, might be easier to hear me. We've done all the top rings, and now we're working on the second ring down. So each cylinder has the second ring installed. So again, we use this device here to put it in the right position, exactly the same distance down from the lip all the way around. So we're measuring this gap right here, and on the second ring down the minimum gap is 0.018, so we're doing 0.019 just to get slightly above the lower limit. So this one needs filing, so pull it out. This is a diamond embedded grinding wheel. So you just grind on one side, and you take the file, the hand file, and just kind of knock down any burrs that are on that edge. So you knock the burr down on both sides. And then also from this direction. So I put it back in. Okay, so we've got the ring back in. Now the feeler gauge goes nicely into that gap. So that's the process on all of these. All right, we got the first piston installed in the number one cylinder, and basically we'll show you how we did that. But there's a ring compressor that we put on top of the piston, and down here we've got new ARP bolts, and we put assembly lubricant on the bearings. Then we have some special lubricant for the ARP bolts that go on these on the bolts down here. You can see this slides real nicely. So we'll start on number 2 next. We've got the valve reliefs going towards the intake. Numbers where you can read them from this direction. And then the stamped numbers on the rods face this direction. Okay, so this is called clocking the rings. Basically, you adjust the gaps on the different rings to be offset. I think we're doing 12, 3, 6, and 9, or north, south, east, west. So 90 degrees from each other. And that helps improve compression and all of that. Okay, the bearing goes in dry, and then we put some assembly lube on the bearing surface. Okay, so we've got these little boots that go on the bolts, and that keeps you from scratching the bore as the piston goes in. So the ring compressor goes over all 3 ring sets. Tighten it.